Hi to everyone. This practice is going to be made with steel 1018. In this case, the first thing that we are gonna do in this practice is to make the tensile strength of the probe of this kind of steel. So here we have the results of the tensile test that we made. I investigated the mechanical properties of this material. I investigated this data from the American Iron and Steel Institute, and the values that I've got was of 29,700,000 psi for the modulus of elasticity, 53,700 psi of the resistance to fluency, and 63,800 psi for the resistance to tension. I also made the analysis of error. The percentage of error in the modulus of elasticity was of 24.04%. The percentage of error in the yield point or the resistance to fluency was of 14.76%. And the resistance to tension, the error was of 22.94%. Now we have the hardness test. The first hardness test that we made in this practice was the Brinell test. We have 3 samples. The 3 of them were the same measure of diameter, and they have the same average, so the result in practical hardness was of 318 in the 3 of them. Then I made the theoretical hardness, and it was of 318.3098, and the one that I investigated was of 126.
The second hardness test that we are going to analyze is the Rockwell test. We have the 3 samples of the steel 1018 and the results of the 3 samples in this practice. The average of the hardness test was of 22.25 in the scale of Rockwell C, and when we convert it to Rockwell B we have 99.5. The result that I investigated online was 71 in the scale of Rockwell B. The last hardness test that we made was the Vickers test. We made this test using the backlight with the specimen steel 1018. This specimen was cut out from the probe that I used in the tensile test, and we have 3 measurements with the average of each measurement and the hardness of each one. In the first one we have 177. In the second one we have 178, and in the third one I've got 204. The average of this practical hardness was 186.33, and the result in the theoretical hardness that I made was of 278. But the one that I investigated was of 131. So there's a percentage of error very small between the practical hardness and the hardness that I investigated in the published manuals from the American Iron and Steel Institute.
The last test that we made in this practice was the impact test. In this impact test, we have 2 samples of the same material at the same temperature. The temperature was of 27 degrees Celsius, and the result of the energy that absorbed each sample was 39 pound-feet and 37 pound-feet in the second one. As we know, the steel has a mountain-type fracture, and since we have this characteristic, we can assume that the fracture is ductile.
The final test that I made was the metallographic test. In this test, we analyzed the count of grains at 100x, 500x, and 1000x. The photo that you are watching in this moment is the one of 100x, and this photo was taken just after I treated the backlight in order to be with a good quality. This photo that you are watching now is the metallographic test at 500x. As we can see, we have a clearer view of the grains, and with this photo I also made the analysis of the count of grains using the formula that we saw in class. Here you're watching the analysis of the quantity of grains that we saw in the other picture. The number of grains that I detected was of 36 grains. So the magnitude here is of 500, and we are dividing between 100 and multiplying this number by the time of the number of grains. So the result was of 900 grains, and to obtain the number of grains in ASTM, we use the second formula, and the value was of 10.81 ASTM. Now the photo that you're watching is the same sample in the metallographic test, but at a higher scale, that is 1000x, a higher magnitude. This is the last magnitude that we applied in this practice, and the important thing to notice in this photo is the clearness of the grains in this magnitude. So the conclusion of this practice was, in my personal case, the experience of making all the materials without the help of my team and without the help of my teachers. I made some mistakes, especially while making the bakelite used in the Vickers test and in the metallographic test, and this caused me to polish the piece twice until I had a better quality of the piece.